But yeah, thank you for being here. My name is Ben Briard. I'm a product manager at Red Hat. I focus in the container space. Obviously, we talk constantly about systemd, Atomic Host, Red Hat Core OS, which we'll be talking about next door after this. All of that stuff is kind of my focus at Red Hat. And we're very fortunate today to have with us all the way from Berlin, Mr. Leonard Pottering. So thank you for making the trip and being here. That's good. Okay, so this session, we're going to cover a variety of things, looking at some of the more basic stuff, and then we'll get into some of the more advanced and functionalities where a lot of people aren't as familiar with. But these are high-value things that my hope is that everybody finds and learns something that you can take home that makes your job and just life better when you interact with the system. Now, a couple things. This presentation is written in a way to where you can just take it, read it, and learn it. So if you guys have other friends or other people you work with that want to, could benefit from this, the slides will be up on the site, so please take them and help them digest it. We are going to go fast, so there's a lot of content. So I apologize if you don't like that. If I have to choose, though, I'm always going to choose too much content over not enough, okay? So stick with us as we go fast. Leonard, why don't you give us an introduction?
Yeah. Systemd, I think most of you probably came into contact with it already, given that it's part of RHEL 7 since a while and kind of like it's a relatively old project by today. So it's like 6 years ago it was adopted by the various distributions, like all the big distributions do systemd these days. Systemd is a bit different from the init systems that came before it. We call it a system and service manager and not just an init system. So it actually has a concept of services that it manages and bring up the system and keep up the system and shut it down again at the end. It is designed around the basic concept of a unit. A unit is, first and foremost, a service is a unit, but there are a couple of other types of units. And they have init dependencies, and these dependencies basically declare how the system is to be brought up and how the individual services shall be restarted and what they depend on and what needs to be started first and second and in which order they need to be shut down and things like that. There are a couple of unit types. We'll talk about that later. But yeah, the basic concept is the unit and a network of dependencies between them. Systemd tracks all processes in the system relative to some service that they are part of. So basically, you always know what are the processes that make up a service and which is the service that a specific process belongs to. This is also hooks into the resource management logic. So we have these service level agreements that you can basically say, yeah, this service, like Apache, gets this much memory and this much CPU. And the other service, let's say MySQL, gets a different amount. One key feature of systemd that I always like to talk about is actually the ability that it can properly kill daemons, which sounds super basic and sounds like something that the prior init systems could do too. But actually, it's much more complex than people think, and systemd for the first time can do this properly. What is that about? It's specifically about the fact that a service usually consists of multiple processes, and only because systemd knows to which service a specific process belongs to, it can properly shut down the service in its entirety, right? This is relevant, for example, when you have Apache and it forks off a couple of worker processes, and these worker processes fork off a couple of CGI scripts or something like this, right? You get this huge collection of different processes, and if you want to shut down them properly, you need to actually know which ones are there. This didn't used to be available in earlier init systems, right, where Apache itself, for example, could be killed, but this would not implicitly also kill the CGI scripts and whatever might have been forked up. One key effect of using systemd and RHEL is that the system boots up much quicker. This is due to the fact that it's heavily parallelized and a lot more on demand, so that only the stuff that's actually needed gets started. There is, what really was important to us was that the entire system becomes more debuggable. And this is for example, every service's output is collected by systemd automatically and written away in something called the journal. And this includes early boot stuff, which is a big step from RHEL 6 times because, yeah, like the only way how early boot logging worked on RHEL is by scraping off whatever was output off the screen, writing to its file. In systemd, whenever something runs, we will collect its output through to this log to std_out_str, and write it away, index, and we'll make sure it will sooner or later hit the log system. So this is actually awesome because, yeah, for the first time, early boot messages are guaranteed to be collected somewhere and hit the logs eventually. Yeah, it's simple to learn, maybe not for people who are used to the systemd ways of doing things because, of course, it's a change from what was there before. But in generally, I'm very sure that people who come from like other backgrounds in System 5 probably will acknowledge that it's easier than System 5 because it does not require you to have a deep understanding of shell and these kind of things. So yeah, it's generally, we believe it's simpler to learn if you come from, like if you're new to the entire ecosystem. But there is, of course, because it is different from what was before, there's some things you need to learn new if we come from System 5 in it. Yeah. And yeah, the last thing is it's mostly backwards compatible, right? System 5 in it, like the concepts have been entrenched in Linux since a long time, so we have to carry on and be able to run System 5 init services for a longer time. And we are pretty good at that. We do not provide 100% compatibility because that's impossible without being System 5 init. But we are pretty close to that. And the few cases where we do know that we are not capable of providing 100% compatibility are actually documented in very much detail. But in essentially, most services should just work fine that worked on System 5 init without modification on Systemd. But there are some exotic exceptions. Yeah, so much about what Systemd is. I hope you have a rough idea, but the short story is a system and service manager.
So we've looked at what it is, just a couple of comments on what it's not. If you guys haven't seen it, this is hilarious. It makes me laugh every time I see it. I can't look away, right? So, you know, there's a concept that like Systemd is eating Linux, right? This idea. It's probably the best way to look at it is it's a series of building blocks, right, that the OS is built on top of, right? It's not just one giant daemon that is eating your system. And I will also point out that this slide is totally technically inaccurate because Systemd should never, ever be capitalized. Okay. Yeah. Okay, so I want everybody to think back. Like, how many of you guys have used Systemd and remember the first time you sat on a system that had it? Like, I vividly remember this. So, like, maybe half the room. And so I'm curious, you know, people tend to range from, like, you know, curiosity or I want to learn more to, like, rage, right? I got a few rays. You guys sympathize, right? So I thought back to when Fedora 15 was when it flipped to the default, right? And I remember when I updated it, I ran into a bump. My wife was, I don't know, I needed to fix it quick. And I basically found footage of what I looked like when I first used it, right? Anyway, if you guys don't like monotone voice or bad jokes, this is going to be a long hour. So anyway, but so basically what we've learned, though, and what we found is over the past 5-6 years is the more people learn about it, right, and get familiar with it, the more they like it, right? It's the thing we see that, like, the more you know something, the more you tend to like it, right? And so for myself, right, once I started reading, using, and, like, diving in, it was like, this is amazing. So now I absolutely love the technology. So again, we've seen this pan out over, you know, all the past years. You've spoken at, I don't know, hundreds of conferences on the subject. So it's been really cool. And yeah, it's a pretty big fundamental change, right? But it's easy to adopt to, and it's not going to be near as bad as when we move to the GNU herd kernel in a future version of RHEL. That's much more disruptive. I'm just kidding. That's not true. Okay, so unit files here's the format, right? It's name.type, right? So service is typically what we generally interact with, but there's many other kinds. God, this clicker is interesting. Okay, so these are the ones that we're going to talk about. And I do want to call out that snapshots are still in RHEL 7, but those have kind of gone away upstream, and there's not something that you typically interact with much, so we're just going to skip over that. This is what a unit file looks like. It's pretty easy to read, right? It's based on the INI file format from the Windows world. So it's super easy to read and understand everything about this, right? You have several different types, like describe the unit, when does it boot, the service, how it's executed, and what the environment files, the user it runs, things of that nature. And the install section is like, think of this as like the run level, which we'll get to in a minute. But basically, you'll notice this is a declarative model, right? In System 5, we were running scripts or programs, right? Now we're describing to Systemd what we want it to do. So this is like the big change. So now that we know what units are, it's really important that you guys understand where they live on the system. And this matters as we modify systems, go through the life cycle, and just regular everyday tasks. So what we're calling the maintainer space is the unit files that come with RPMs. Those are under user, lib, systemd system. By the way, feel free to take as many pictures as you want. The slides will be online, but take away. Anyway, so under user lib, are we supposed to modify files under that? No. All right. We put our changes in our custom units under etc systemd system, right? And if you have identical names, the one under etc will take precedence, right? So that's where our changes are going to go. And also for non-persistent runtime changes, those are going to go under /run systemd system. Now what's nice is systemd delta is a tool that will show you any of the overlaps or changes that are on your system, right? So this is really useful to just view what units have been altered on my box from their default state, right? Super handy. This would concepts like this just weren't possible and don't exist in a System 5 world. All right, so this is the number one thing that always comes up every time we talk about systemd. I kid you not, when I was downstairs registering for the conference, somebody said, "Why did you guys break the service command?" And I said, well, we actually fixed it, right? Because now it works like every other command in Linux, right? You think about service, I know it's muscle memory, but normally you have the command, verb, and then what you want to do the action on. So I would argue that service is wrong, but if you like service and check config, all that still works and it's backwards compatible, so everything's fine. Okay. So a couple things. One thing, since Leonard mentioned we're doing things in parallel now in systemd, so part of how I keep that straight in my head on the order of the command is that we can glob units onto the end. So I can start or restart 10 different units if I want, but I know I have to glob them at the end, right? Don't worry about typing service. We'll assume that if you don't provide the service. However, if you're going to do something with a socket or a different type of unit, make sure that you spell out the full name of that unit. And then shell completion, if you can read tab on your keyboard, you're probably not using tab completion enough. So that's kind of my watermark, except for my brand new laptop. But anyway, so yeah, definitely leverage that because it works incredibly well with system control. All right, so checking the status is a similar concept, right? We correct the command structure, right, with system control. And look, we get super useful output. What did this look like in RHEL 5? It said, Apache's on, I promise, right? Now we get, the unit's loaded. Oh, look, it's set to start on boot. It's active, and yeah, it is running. Oh, look, here's my uptime. Here, relevant documentation. I love it. The main PID, you can see all the worker processes. Hey, look at this, current traffic. I mean, this is great. And then recent log messages. All in one shot, right? This is super, super nice and handy and just, again, everyday life, make it better, right? Yeah, so you guys didn't know Conan likes systemd, but he's on board. Okay, now, how do we look at the system, right? So one of the things I find the most helpful is the system control -T for type service. So I'm going to filter the service units. This is going to show you what's running on your box, okay? Very, very handy. The next one is similar to check config. Show me everything that's on and off on my box. So list unit files is more like kind of what we had in the past, but frankly, the top one is what I typically go to. And then if you want to see if anything's in a failed state, system control -failed. So it's, again, really handy information right at your fingertips. All right. Enabling and disabling services, again, super simple. Everybody can understand this. What I like is down here at the bottom, though, where you can flip it on to start by default and enable it in one command. It just, I don't know. I feel like a badass every time I type that, right? And again, and you can still glob units and everything, and it works with disable, and it just takes one thing out of the process, right? So it's really nice. A couple other little quick highlights here is system control can connect to remote host. I mean, yeah, it does use SSH, so it'll just save you a few characters of typing SSH, and but it's super handy. Just be careful, put the right host name in, right? Little things like that. But it's quite powerful. If you guys use RC local, I would first suggest that maybe you should break that up into unit files, right? And just drop in little one-shot unit files that will execute the script or whatever. But if you do want to use RC local, you can. Just make sure you make it executable, and then it will run like you always have. And then there's other good tools for analyzing the boot process, and single user mode basically still works the same. Okay, targets. Think of a target as a group of units, okay? This is going to replace the concept we know and love of run levels, right? And we have meaningful names now, so no longer 3 and 5, or the most ones where we live is now multi-user and graphical target, and we just kind of let 2 and 4 go because nobody ever used those anyway. If you use those, I'm sorry if I offended you. Anyway, this just demarks like a place in the boot order, or like just a group at a certain point in time, right? And so when you need to, there you go. So if you want to view where you're going, so get default and set default are going to change where the system boots to, right? So on a rel box without a desktop, you will go right into multi-user mode, right, as expected. If you wanted to change, you could type, set default graphical, right, and then we'll just bring up the delta to get to that group of units, right? No more like killing everything and bringing it back up like we did in System 5. And if you do need to change at runtime, it's isolate to actually get to that unit. All right, and then init tab is gone. You're welcome to still edit the file, we just won't read it, so be aware, right? Okay. Again, I apologize for going fast. There's a lot of stuff we're going to get to, though. Socket activation. Everybody likes ZynetD, right? Super cool. Socket activation is really, really cool, and actually super relevant technology right now as we look at how dense things are going. And with systemd, we can apply socket activation to many, many, many other use cases than like just what ZynetD covered. But here's how it works, right? So you have a corresponding socket unit, this is its own unit, that maps to a service unit. And you'll notice the name is the same on these. If you have a RHEL 7 system with the TFTP server package installed, you could still run it with ZynetD, that's fine. We do drop in 2 unit files, so you can also type system control and enable -- now, or just start the socket, right? And then we'll be listening on port 69. And then once you get an incoming connection, boom, we launch the server, map the route, and hand out your NBP or whatever you're doing, your SIP phone or whatever you're doing with TFTP, right? So this is super cool, but you see one calls the other. We use this for Cockpit. Has anybody here used Cockpit? Okay, so you all have homework now. If you didn't raise your hand, to go try Cockpit. It's super, super cool. And it's awesome. It's how you drive Linux, and it puts it all into a really nice UI that is live with the system. And you can also think of this as like a GUI for systemd if you want. But when you think about a UI, right, you really don't want it running 100% of the time. It should really only run like a tiny fraction of the time when you're actually on it. And so Cockpit consumes socket activation. So here, same kind of thing, where the socket maps to the service. We see that we're listening on port 9090, and as soon as we get a connection from your browser, we run a pre-script, and then we actually start the web server, and it's amazingly responsive. You instantly hit the login page. And when you close your browser session after about 2 to 3 minutes, this whole thing goes away. Pretty cool, 0 footprint, and it's just cool functionality that's just baked into systemd, right? It's super easy to leverage. And you guys can extend this to a lot of other things. There's even a socket proxy that you can use for services that don't have native socket-aware capabilities. All right, so timers. Think of this as like native cron type capability in systemd. We're not going to deprecate cron until RHEL 7.6. I'm just kidding. We're not getting rid of cron. It's not going anywhere. I promise. I promise. I told you, if you don't like bad jokes, it's going to be log hour. So the timer, right? We can do a lot more things that are fine grain than you can do on cron. You can do a lot of stuff on cron, but it's more effort, right? So like time something to run after startup at a certain interval, and like if you do persistent true, it will like remember the timer if the system's offline or turned off. So it's pretty powerful with how you can implement things in timers. It's also easy to manage on a system if you have lots of users writing into the same cron files. Maybe they're using their own, but if they're mixing them together, it can be a little chaotic. So again, a nice capability that's there that I want to make everybody aware of. Okay, so again, I promise we're not deprecating cron. Okay, now that we've looked at kind of what units are and some of the basic types, hopefully we all have a pretty good understanding here. I do want to talk about customizing them because this is when we get into really powerful, relevant parts of systemd. First is like viewing a unit. Yes, you can always view the actual unit file, but I like to just do system control cat unit, right? I mean, it makes sense. Cat is really slick. Well done. So then we'll page it out to less or whatever the default pager is, so you get a good clean view of it. But we said earlier this is declarative, right? So we're describing what we want the system to do. So it's important to know what's available, and you can list all capabilities. It's like 200, so it's a lot, right? You're not, it's a lot to digest. But there are some main ones that you'll want to leverage. And when you take a rel system, there's a whole bunch of units already on there. So if you need guidance for writing them, check out the default ones that we ship with the operating system. We can also query individual characters. So system control show -p restart will print out what the restart is set to for this unit, right? Which will default to no. We got a couple other really useful ones here, and yeah, okay. So we can modify unit files in several ways. One is we can just drop in a brand new unit file, like complete head to toe, into etc. But there's better ways to do this. Are we going to modify what's under user? Thank you. He's my plant. Okay, so, but what's cool is we can use a drop-in concept, right? And we have inheritance from what we ship. So if Red Hat makes changes over here, or any other vendor or whatever, we'll pick up those changes, but we'll still apply your customizations on top of that, right? Which is really, really slick. So to do that, just make a directory that corresponds to the unit name. So in this example, httpd.service.d, and name the config whatever you want. And I'm going to change these properties for the Apache config, right? So what is this going to do? If it dies, it's going to automatically restart for me. How cool is that? Right? The common deployment pattern we see is people run one application to one VM, right? You guys know what I'm talking about. I see head nod. One guy's on us. That's great. So we have this powerful multi-user operating system, right? But because of like management and other things, and just it works, right? So people do one app to one VM a lot. Why not make that one app super resilient, right? It's one command, right? It's one drop into change. This example, I'm also locking it to the first 4 cores, which is pretty cool to just hard set that in the unit, and I'm effectively turning off the killer. Now, once I put these into my file, I notify systemd that we made changes. So daemon reload is how we tell the system that I made changes. So don't forget that last step. It is safe to run that on a live system in production, so don't stress about that. So it's important to know how that works manually. So if you're doing config management systems with like Puppet, Ansible, Chef, or whatever, you understand where the stuff lives and how it works. If you want to also do a drop-in, like if your hands-on keys, it's really nice to just do it directly through the system control command. You type edit. We saw cat will show it to us. Edit will actually drop us into your default editor, which of course is VI, right? There you go. And so, again, this case, I'm just going to set the restart policy. Again, that's one of my favorite things that I always do on systems. And then as soon as you quit the file, that's how we exit an editor, right? Then I go to system control show if I want to view it, and I can see it's instantly applied. We don't do daemon reload, that happens for you. So this is a really nice, easy way to get it done. Now, if you have a drop-in on your system, under status, we'll actually show you that you're using a drop-in, so you know that you're working with something that's been modified. How cool is that, right? Again, just great visibility into what's going on the system. That's Club Soda, and Red Hat does not officially condone excessive use of Club Soda. Okay. Now, the security capabilities is a big deal, and this is one of those areas where I think isn't well known enough. So Leonard's going to walk us through the security side.
Okay. So because systemd manages all the services, it was a straightforward decision for us to actually improve on that and to make sure that services are sandboxable. This is opt-in stuff. It's not enabled by default for services, already for compatibility with System 5, because if we sandbox all the services just like that, then things would break. So most of these things are opt-in. And there's more than on these slides, but these ones are pretty interesting ones for the beginning. Like one of the really obvious one, which we actually enabled across the distribution for many services where this makes sense, is private TMP. It basically just takes a Boolean, and if you turn that on for a specific service, then that service will run in a mount namespace. It will basically see the host file system identical to every other process would be, with one exception, which is /temp and /vartemp will be a private version that is like where it can drop files and nobody else will be able to see them, and it's basically its own private namespace. This functionality removes a big chunk of the vulnerabilities for services, because people, when they write their scripts, they tend to use like guessable names in /temp to drop their stuff in, which is generally a DOS, right? Like because if something else runs there and also uses that name, it can use the name first, and then bad things happen, right? So if you set private TMP equals yes in your unit file, you completely remove that vulnerability, because that service will get its own version of /vartemp and /temp, and nobody else can see that. If you want to investigate what your service actually wrote there, you can still do that. It's just a minor rearrangement of /temp, because the actual temp that the service sees is just the one called /temp systemd private, and then there's some random stuff to make it non-guessable, and then the unit name, and there you see what's actually in there. Another one is private network. Private network is actually super powerful. It's like we have so many services that actually don't need network access. With private network, which is again a Boolean, you turn it on, and then this service can use the file system and everything else like everybody else. But the network is isolated from the rest. It will just live in its own little network namespace, and there's going to be exactly one interface in there, and that's a loopback device, nothing else, right? So it's a very, very efficient way to lock something down, because you know that if you turn it on, that service will not be able to dial up into the internet and connect to weird stuff, or even be connected to the other way. So it's very simple, just a Boolean, and if you have services like that do not need internet, right, then turn it on. There's another one, joins namespace off. This is actually a kind of dependency that you can define between different services, and it basically allows you to have two independent services, but still make them share their temp and vartemp even though private TMP is on, and still share the same private network even though private network is on, right? So this is, for example, useful if you have two servers that belong together, and they should be locked down as much as possible, but they should still be able to communicate via IP with each other, but not with anybody else. And in that case, you would just turn on private network and would set a joins namespace off dependency between them, and there you go. Yeah, they will only see a loopback device. They cannot connect to the internet, but they can still connect to each other. And then, of course, there's integration with SLLinux, and you can set an SLLinux context explicitly in the unit file, if you like. One that's really important, actually, is protect system, right? Because we have, like, I mean, he always made a joke just earlier that you should not modify the stuff in /user. Protect system is your way how you can tell the service manager explicitly to make it impossible for specific services to modify /user, right? If you enabled it, superficially it's a Boolean, but actually it takes a couple of other values too. But if you turn it on for a service, then it basically means, yeah, /user becomes read-only for the service, which is actually something you should basically turn on for all services except for something that actually wants to upgrade the system. Because for everybody else, they should not be able to modify your operating system. It should be immutable to general service, right? Like, because you don't want that if Apache ends up being exploited by some attacker, you don't want the attacker to be able to modify the OS. There's protect home, which is related to this, and it protects the home data, because most services, they should not be able to modify the stuff that's in /home or in /root. It should be, yeah, it should either go away entirely, or it should be read-only. And most services probably want to have it go away entirely, right? Like, if you run Samba, maybe not set that, but everything else should really set that. And then there's private devices. It's, again, a Boolean. If you turn it on, then the service will see, again, the host file system like everybody else would, except for /dev. /dev is replaced by a minimal version. And that /dev, there will only be dev urandom, dev random, dev null, and these kind of things. But there will not be any devices that refer to actual physical hardware, right? There's not going to be dev SDA or dev loop or all these kind of things. There's just going to be the API file systems, right? Like the Unix things like dev0 and dev null and so on. It's like, because there's very little software, very little service that actually should be able to access your physical hardware, this is also a pretty safe bet that you want to turn on most services, and you lock them down, you make them secure, and you can be sure that when somebody manages to exploit your service, he will not be able to write directly to your raw hard disks anymore. Yeah. And there is read-write directories, read-only directories, inaccessible directories. These are actually closely related to the ones from the slide before, but they allow you to explicitly mark any directory you like as read-only or as inaccessible or as writable, right? So you can basically say, yeah, like protect system is this one-stop solution. You just turn it on, and then /user becomes read-only in a couple of other directories. But if you want to have parts of user writable for some reason, you of course shouldn't, but mark yourself out, then you can use these options and define explicitly for all the directories you like where they should be readable, if they should be also writable, or if they should be replaced by an inaccessible file or directory that's like if you manage to open it, it's going to be empty, but yeah, it's a masking concept. Then there's no new privileges, which is a very simple Boolean. It exposes the kernel concept. It basically says that, yeah, anything that runs in the service shall run with the privileges that systemd passes to it, and it should not be able to acquire any new privileges. This is specifically a way to turn off like setuid binaries for that service, right? So you can be sure that, let's say, your ping command is exploitable, right? Like, because ping is, as an example, is usually the one setuid binary everybody thinks about. Yeah, it wouldn't be possible anymore because security elevations for that specific service will be turned off. And there's capability bounding set. Capabilities are a concept that has been around in Linux for a while. It's basically a way how the root user is split up into little bits instead of being this one big thing, like that root has access to everything and everybody else to nothing. It's an attempt to split up root and has been around in Linux for a long time. With systemd, you can set capability bounding set on a specific service and then basically run something as root, but take away these capabilities. For example, you can use it to turn off the ability to change the system clock, right? Like, there's one capability that is called capsys time, and if you have it, you can change system clocks. If you don't, you can't. Now, almost no service should be able to change the system clock. The only one who should be able to do that is, of course, NTPD, right? So that's, for example, a capability that makes sense to remove from all servers that you have, with the one exception of NTPD. Yeah, it's your joke, but anyway, so much about security. There are a couple of other features. They're awesome. You should really consider setting them if you write your own service files. It makes the system much more secure. It would have been great if we could have turned them on by default for all services so that you have to opt out. But again, due to compatibility, we can't really do this. So it's basically on you to turn them on. And many of them are very, like, they're almost no-brainers, right? Like, because, yeah, for example, turning off the clock capability is something that, yeah.
So quick thing, how many of you guys, this was new, the security side of this and doing sandboxing? All right, so how many of you guys think this looks like really cool and useful, like for in-house apps? I mean, this is pretty powerful stuff, right? Okay, cool, thanks.
Yeah, let's talk a little bit about resource management. Resource management is very important in the systemd concepts, and it's like, yeah, whoever actually deploys systems and has like reaches a certain level of density needs to care about these kind of things. In systemd, we expose them through three concepts. it's implemented, or let's jump one slide ahead, we come back to this one earlier. The three concepts are called slices, scopes, and services. Services we already know, they are what you think they are, but we also have scopes. Scopes are basically a lot like services. The one major difference is it's not systemd that actually starts the binaries inside of this concept, but it's somebody else who starts it and then tells systemd to manage it for it, right? So in all other ways, it's like a service, right? It's just that systemd is not the one who originally started it, it's somebody else. And then there's the third concept, which is called a slice. A slice is basically a way how you can slice up your system's resources in a hierarchical fashion, and then you can assign the services and scopes to these slices, right? These slices can be like any deep as you like for example, you can have for your 10 customers, you can give a slice each, but then for some of these customers, you can further subdivide it if you like. These concept, services, scopes, and slice are mapped on this kernel concept of cgroups, right? Like this is what this slide is about. It's basically, it's how the kernel internally and the basic API, how resource isolation works in Linux kernel. So if you think cgroups and then think systemd, then slice, scopes, and services is what you have to map it to. The cgroup hierarchy is still very relevant to you if you use systemd, right? Like it's nothing you can forget about. On systemd systems, the cgroup file system, like cgroup is exposed as a file system to user space, is available on /sys/fs/cgroup. This maps to the root slice and systemd. These slices, scopes, and services, they have these properties. Like slices, scopes, and services are, by the way, units that we talked about earlier, right? And they can have these properties. Like one, for example, is CPU shares, which basically, like we'll get into that a little bit later in more detail, but it basically is a way how you can say, prefer giving this service CPU over this other service of CPU. It's based on a share system, so you basically give it a weight. And by default, the weight is 1024 for everybody, but it's then up to you to lower the weight for some service and increase it for others. What's really important to say that the resource management is really about contention, right? Like it has no effect if the system is idle anyway, right? It's really about what happens if the system is under pressure, like which services to give more resources to and which services to give less resources to. If you have a complex system, then it usually, the cgroup arrangements look like this a little bit, right? Let's see if that's, it works. So by default, systemd will actually create two major slices. Or first of all, we'll create the root slice, which always exists. And then we'll split that up into the user slice and the system slice. And the user slice is then basically split up for a sub-slice here, user 1000, user 1001, and I think we actually have this here. So basically that every user, that the 1000 and 1001 is actually the numeric user ID. So that basically, you separate the user stuff from the system stuff, and then for each user you give them like a separate slice too for resource management purposes. This basically enables you to say that, if you have 5 users on the system, you can be sure that they each get an equal part of the available resources under pressure, but not more than the others. More interesting, I guess, for our RHEL deployments is the system slice part, because, every system service that you have will get a service that is attached to the system slice by default. You can actually rearrange this hierarchy as you want. The split up in user slice and system slice is just the default that we do from cgroups upstream. You can, from systemd upstream, you can rearrange it any way you like and attach services to slices of your own choosing completely freely. Talking about the CPU shares concept again, like by default, every service gets CPU shares equals 1024. But if you change that, like, where's there? Like for tomcat.service, we now increase that to 2048. What that basically means is that if the system is under pressure, then Tomcat will get twice as much CPU time as the other ones will individually, right? CPU shares is a property that you can set on this specific service, but you can set also to the slice as a whole, right? So if you, for example, want to make sure that the user slice always gets enough resources against the system, then you can set CPU shares on the user slice as a whole, and then everything that's below it, all the slices and the scopes and the services below it, can only redistribute among themselves the little resources they got. On a real-life system, you can use the systemd cgls command to actually see what the cgroup setup is like, right? Like this is an excerpt of this, where you basically see that P81, where's this thing? Where P81 is shown as being in the root slice, and then you have, this one actually shows another slice, which is machine slice, which is used by virtualization managers and by container managers. It's where they place their stuff. And then you see the user slice, and there we see one slice created for the root user, another one for the user 1000, and so on. And then below this, you always see the processes that are part of this. Okay. Yeah, there's another tool called systemd top, which is basically, it shows you the actual resource usage so that you can have this feedback, see what's consumed, and then set the limits on things. Yeah, the resource manager, we have these tools for this to actually control that. We don't have too much time yet, so I'm going to...
Yeah, do you guys want cgroups or what's coming next? Coming next, all right.
Okay, so just briefly, with that we can control CPU and memory and I/O. And most interesting is a recent addition of that you can put limits on the number of tasks. And
no more fork bombs, you can prevent that.
This is basically our last slide, which is looking forward. So what's coming next in the next RHEL versions? One concept that we'll add is called portable system services. It's currently being merged upstream. It's basically, it's taking parts out of the container concept and just like applying them to normal, regular system services. Specifically, that's resource bundling, right? This is what containers do, and stronger sandboxing. And then by this, we basically create a way, like it's ultimately, you know, if you ran system 5 init services and played around with cgroups, it's basically that, but a lot more integrated. Yeah, it's supposed to be something where if you don't want to go for full containers and you would like to retain the usual service like workflow, it's something in the middle basically where you can do like ship things in one image and then run it as regular service. Independently of this, there's going to be some OCI compatibility. OCI is the open container infrastructure thing. Basically, this means that like it's my intention that we can run OCI runtime like OCI containers directly in systemd without having any further components in place. It's basically, I mean, we have this little tiny container manager anyway called nspawn, and we want to extend it to that point where basically OCI can just run in like a native systemd concept. There are more sandboxing features coming. There's the big thing coming, which is cgroups v2. It's not going to hit RHEL anytime soon, at least not by default. It's a reinvention of the cgroup, of the resource management stuff that we had, and it's going to make everything so much better, but it's still a little bit out. Yeah, one last thing is IP accounting network filtering, which this hooks actually into cgroups v2. There's going to be, or there already is in systemd upstream, but not in RHEL yet, the concept that you can do IP accounting per servers. So you just turn it on, and then every packet will be counted that the service generates, and you can see how much that is. And you can also do a little bit of like firewall-like features. So you can basically say, yeah, HTTP shall be able to access these IP addresses, but not those. And then you can write the direct into unit file, and it's nicely dynamic. You can change it at any time. To me personally, it's a major step ahead because it allows us to do local firewalling where we're actually aware of the service concept, because that's traditionally not available for firewalling, right? Like the way how you do firewalling is you bind everything to the port number, but that's an opaque number, and today's service is not as matters, like it doesn't really tell you what kind of service it really is these days, because many protocols use dynamic port numbers these days. But with that concept, however, we can resolve that and basically say, yeah, it doesn't really matter what port that service actually uses, but that service should only be able to access that network and nothing else. And that's all we have, I guess.
Okay. Hey, so quick, I definitely want to hear back from you guys. Please take the time to fill out the eval for this. I think it would be interesting next year to like tear this deck down and just cover all the new stuff, right, that's come out for the next version. But let us know what you think, right? Because we obviously want to keep this relevant for you guys and what's most valuable. So anyway, thank you guys so much for coming, and come grab us if you want to talk or have questions.
Thank you.